Good morning. Let us continue with solving our try questions. It said find each right to answer in the standard form. So looking at our questions, there are no distributives, so we just go ahead by multiplying the highest degree first, followed by the second, then followed by the second, and our constant. So the first, which is 20y squared minus 13y squared, plus our second, which is 12y plus y, and our third, which is minus 2 minus 10, and this 20 minus 13 gives us 7y squared plus 13y minus 12, and that is our answer. Okay, with our second question, we have a distributive, so a quick one. We multiply 2 by 2b squared, 2 by 2b, and 2 by negative 1. So in doing that, let us write this again. We're going to have minus 4b minus b squared plus 2. Then plus, now we'll multiply 2 times b, we have 2b squared. Then plus 2 times 2 give us 4b, and 2 times negative 1 gives us negative 2. So in adding, we add with the same exponent. So negative b squared will be added to 2b squared, and negative 4b will be added to 4b, and 2 will be added to negative 2. So with our first one, I'm going to put 1 on it, and this will be our second, and that will become our third. So our first, we have negative b squared plus 2b squared. Then our second, we move to negative 4b plus b. Plus 4b, should be plus 4b. Plus 4b. Plus our final one, we have 2 minus 2. So we could see that we are going to be left with negative b plus 2b. This gives us 0, plus that gives us 0, and the last one also gives us 0. So our answer is 0. Now our last question, we have negative f, and we have also negative f on the other side. So it means that we can add that. The second one, 5f to the power of 2. Yes, we also have another to the power of 2. So this can also be added to that. And a constant of 5, there isn't any constant, but there is 3fx. So in that case, we leave them. So in solving, we write the highest degree first, which is 3f exponent 3, followed by our second degree 5, so which we are going to solve. So 5f squared plus, let me put this in bracket, so 5f squared plus f squared. Then our next is minus f, which is the second, and our last, which is our constant, we have 5. So in simplifying, we have 3f to the power of 3, and 5f squared plus 1f squared will give us plus 6f 3, and minus f will give us minus 2f plus 5. Now looking at this, can we simplify? Now this should be 4 because this should be 2. So we're going to have, so since the exponents are different, we cannot simplify, and that is our answer. On our last check question, we had to subtract. So we're subtracting z to the power 2 minus 3. So this 2 minus makes it plus 3z squared. That will move to with an exponent of 1. So we have 2z minus 9z. And the last one, we have a constant. So there isn't any constant in the second term, so we leave it as our minus 5. So when we solve that, we are going to have 4z squared. Then 2z minus 9 will give us minus 7z minus 5. And that is our answer. The third one, in solving, we go for the first, writing it in the standard form first. So we're going to have 7r squared minus 16 will give us plus 16r squared. Then the next one we go for 8r minus 7 will give us plus 7r. And the last one we go for our constant, minus 14 minus 3 will give us plus 3. Now in solving this, we are going to have 23 r squared, then we have plus 15 r, and minus 14 plus 3 will give us minus 11. Now the last one, if we're solving for the exponent of 2, we're going to have minus 8 to the power of 2 minus 5 h to the power of 2. The next one, we have h minus 2h. This 2 is going to give us minus h. So we're going to have minus h minus 8h, because minus and positive gives us minus. And the last one, there is no constant in the first one, so we leave it as minus 2, which is plus 2. So in solving that, this gives us minus 6h squared. Then we have minus 9h plus 2, and that is our final answer.